Hi, I am Giri Srivastava, and today I am going to discuss about IBM Netezza data warehouse appliance. So before getting into this Netezza, let us talk something about the appliances, what the appliances mean. The appliances, that is a black box solutions, which are commonplace in the IT industry. We all are familiar with how they are having simplified operations and revolutionized entire markets with a networking devices or networking appliances. For an example, a networking box like firewall or ASA boxes or CSM boxes, it will give you the functionality to create a multiple number of users or multi-users network in a simple or in their homes in a matter of minutes. Another example of this type of appliances is the iPod. You can see about the iPod, the advantage of the iPod. If we want to listen any kind of music, then we can go for this type of iPod as compared to PC and systems or laptops. It's a very low cost and very easy to install. So in place of listening our music, we can go for these iPods. The iPod is a greater example of an appliance that are simplified and revolutionized digital entertainment instead of the PC and the laptops. They do only one thing, but it is better than the alternative, which is PC and the systems. This is only a plug and play and simplified interface, which is a true appliances is also telling the same thing. It is our dedicated devices, the optimized for purpose, complete solutions, the fast installation, very easy operations, standard interface, and low cost. Let us discuss something about the Netezza 1000. Netezza 1000, it's a kind of Netezza data warehouse appliance which will provide you the functionality to store your data into the racks, or you can say that the different racks are available inside these kind of boxes where we can store our million or trillions of data at a single time, and these all data are distributed across these all racks or disks, you can say. So the IBM Netezza 1000, formerly named as TwinFin, models include hardware configuration of single rack or multi-rack configuration. As I said, we are having a single rack or multi-rack configuration in Netezza 1000. Within each rack are numerous components that work together to provide asymmetric, massively parallel processing of Netezza architecture. The key hardware components include the following: snippet blades, it is also called as S blades, hosts, and storage arrays. This is three kind of Netezza servers or Netezza boxes, which you can see in the figure. The first is the model number 1003. It's a kind of boxes which are having the number of S blades is 3, 1006 the number of S blades is 6, and 1012 the number of S blades is 12. As let me tell you one thing, in one single S blade the number of snippet blade is 8. So when we talk about in 1003, the number of snippet processors are 3 into 8, that is 24. In 1006, the 6 into 8, the number of snippet processor is 48, and in 1012, the 12 into 8, or you can say that 8 into 12, the number of snippet processor is 96. As like same as disks. Disks in one S blade we are having 8 disks. So 8 into 3 means 1003 we are having number of disks is 24. The 1006 48 and the 1012 96. The data uses, you can store the data, how much data you can store inside this 1003 is 8 TB. In 1006 16 TB, and in 1012 it's 32 TB. Let us talk about the technology. What kind of technology this Netezza boxes can handle, and what is the technology is behind us, behind this Netezza system. The Netezza appliances use a proprietary asymmetric massive parallel processing called as AMPP architecture that combines open blade based on base servers and disk storage with the proprietary data filtering process using field programmable get arrays FPGAs. Netezza proprietary AMPP architecture is a two-tiered system designed to quickly handle very large queries from multiple users. The first tier will handle the high performance of SMP host that compiles data query tasks received from the business intelligence applications and generates query execution plans. It then divides a query into a sequence of subtasks or snippets that can be executed in parallel and distributes the snippet to the second tier for execution. And the second tier consists of multiple number of snippet processing blades where all primary processing works of appliance is executed. So the total idea behind in this technology is the Netezza appliance follows the asymmetric massive parallel processing architecture, which will provide the two-tier system design for quickly handled and very large query for the multiple users. From the two-tier, the first tier of this highly performance Linux SMP host, which compiles the data query and which is text from the business intelligence applications and generate the query execution plans. This is the work for first tier. And after generating the execution plans, it will divide into two sequence of subtasks or multiple number of subtasks or the snippets that can execute it in parallel, and it distributes the snippet to the second tier for the execution. Means in the first tier it will receive the query and it will divide it into different processes or different tasks, or you can say that the subtask, and it will send it into the second tier for the execution purpose. The second tier will receive it for this multiple number of tasks or multiple number of snippet processing and send across the different blades for the execution purpose, where all the primary processing works of appliances will be executed. Let us talk something about the traditional data warehouse complexity. In this figure, you can see that how data are complex across the server. When we supposed to add something inside the database server, or we want to talk or we want to communicate with the database, it seems. You can see in the figure how we are requesting for any kind of data from the database and how it is retrieving the data from there. The complexity is very high, very high. Suppose if we want to communicate with the 100 user and trying to retrieve the multiple or millions or trillions of data from the data warehouse, at that time what will happen? Definitely the traffic will be too much high. So we are simplifying our full architecture with this Netezza data warehousing appliances. So what it will do is, the complexity of the data will gone. It is very less. Let us talk something about the appliance architecture. In the figure, it is clearly mentioned that the Netezza AMPP architecture, asymmetric massive parallel processing architecture. You can see here in the figure the Netezza appliances, we are having multiple number of disk enclosures and we are having multiple number of S blades which is connected through the host with the network fabric. And finally we are having the applications. So whenever we supposed to retrieve the data with the application will communicate with the host. Host will go to the S blade and S blade is having the capacity to retrieve the data from the disk enclosures. And as I discussed earlier also, we are having the two-tier the system over here inside the AMPP architecture. One is called as a S blade and one is called as a retrieving the data for the execution. So you can see here, suppose if we have created or if we have listed out the SQL queries as select district, pro product GRP, sum, max, from monthly RX and whatever, where month equals something and the market equals something and the specify is the something. So if we process this, if we want to process this query into our this FPGA, then what will happen? Just have a look on this figure. You can clearly understand. So first the query is dividing into different parts as it does the first tier, and in the second tier what it will do is it will send for the execution, and in the second tier what will happen is it will do its task and finally it will give you the output as it is doing in the final stage. So you can double click on that. It will start its server and the spools. You can see the IBM Netezza software emulator for developers version 6.0. You can see here the host VM is just stopped and the spoo VM is just stopped. So we'll click on this start. So you can check here, it is showing that the starting host, checking host VM configuration. So after checking it, automatically it will show you that host is started and the spoo VM is also started. Host powered on, waiting for system startup. Give some seconds to start it. So you can see here it is discovering, it's running, everything is working fine. VMware tools is started, host network stack is started, host is started, starting spoo, checking, and the solve. Spoo is started, waiting for NPS subsystem started, NPS subsystem stopped and starting. So it is telling that it's initializing. Once it will get it done, it will tell you that you are online. It is going for pre-online, then resuming, and then online. So you are complete. Now we'll start with our putty. We'll put this IP address into it, 192.168.196.130, and then now it will ask about the login ID and password. Give a login as ng, and once it will ask for password, then give ng as password also. Now it is asking for password, so let's give the password as well, ng. Let's see whether it is correct or not. Once again it is asking for passwords. I think I have given some wrong. So now ng is the username and password, so we have connected with this ng. Now let us talk something about the Netezza database systems as well. Let's go to that prompt and let's check whether this ng-SQL command, what it is doing. ng-SQL. So it is telling that welcome to ng-SQL, the IBM Netezza SQL interactive terminal. Press /h for the help with the SQL commands. Press /word symbol for help of the internal slashes commands. /g for terminate with a semicolon to execute query, and /q for quit. Then this is a system and admin, so you can press here /h for any kind of help. So it will tell you these are the help is available over here to create tables, to delete tables, to create, alter, modify, views. Everything is present over here. So you can take the help of this for the creating of tables. You can create the uses, you can create the external files, you can create the different databases over here. Or it will be better if you create a table over here only. So let us try to connect with this Netezza system and try to execute some command. As I told you, all data are distributed across all the CPUs. So let us create one table and check out whether all the data are distributing across all the SPUs or not. Let us connect first with the system. So for that we will write ng-sql. So it will get connected with the admin. Now let us create one table. Create table one having some values called as id and name is varchar and having some value 20. Distribute on id. Sorry, it is getting stuck, and the id it is trace. So it is telling that table has been created with the distribution. So we are giving the distribute on means we are trying to distribute our table data across the SPUs. Okay, we are trying to distribute it, whatever the data. Suppose we are having a multiple number of data, millions or trillions of data is present inside this table. So all the equal data or nearly equal data can be distributed all across the SPUs. So let us insert some more data inside this. Insert into table name values is having as I said, this is not enforced with the primary key and foreign key constants, so you can insert the duplicate keys. So I'm trying to insert some values over here, and as I said, it will store this all data and distribute across all the SPUs the nearly equals data or mostly equals data. You can see all the data. This all data are inserted over here, and as I said, it is not enforced with the primary key and secondary key, because we can create the primary key and foreign key constants over here, but it is not enforced with that. Now let us check how it is distributed across all the SPUs. So for that purpose, we'll write select id comma name comma data slice id from the table name. So it will show you the nearly equals data or equal data are distributed across this same SPU. The 1 is stored in the SPU number 4. The 1 2 are stored in SPU number 1, and the 110 is stored in spool number 3. This is how the data are stored inside this Netezza all across the spools and distributed across them. This is all about Netezza Data Warehouse Appliance. I hope you have enjoyed this video and got some knowledge on Netezza Data Warehouse Appliance. Thanks a lot for your attention, and please feel free to mail me for any query on girish092.ch@gmail.com.